Okay, on 8.4, every square matrix can be associated with a real number called a determinant. The definition of the determinant of a 2 by 2 is that the determinant is this, and they look like absolute value bars, but that's not true. You always have to look at the context of the problem, because that represents the determinant when you're talking about matrices. So look at the context, but the determinant is the cross multiplication, subtract the other cross multiplication. So be careful of this. Is it an absolute value? Is a determinant? Is based on what kind of a problem are you looking at? So on this bottom one where we're finding the determinant, you're going to cross multiply 8 and 1, subtract the cross multiply of 15. What I'd like you to do is try 2 and 3 on your own. Do 2 and 3 on your own with that. The next thing I'd like you to talk about is the determinant of a 3 by 3. The determinant of a 3 by 3 has a little bit more unique properties to it. And we're generally going to just call it from the row 1, even though you can take it from other rows and other things. We're going to come from row 1 on our information. And when we do that, we're going to take the 1, and we're going to cross off its row and column and look at the resulting and multiply that number that we took and multiply it to the determinant of that leftover 2 by 2 matrix. Then we're going to subtract the next piece, so 4, and we're going to do the same thing. We're going to cross off its column and its row. We're only going to look at the 4 part of it, and we're going to its resultant leftover matrix 2, 0, 3, 2. And its determinant. Then we're going to add the last one, which in this case is a -3, and we get 2, -1, 3, and 5. This process is always the same. It's always plus, minus, plus. It's always going to follow. So if I had a 4, it would go plus, minus, plus, minus. If I had a 5th column, it would be a plus, and then a minus, and then a plus, and then a minus. And it always goes that way to be able to solve this down. So the determinant of this is 1 times -2 subtract 0. -4 is 4 minus 0. -3 is 10 plus 3. So here I get -2 minus 16 minus 39 for -57. So you take the first term, multiply by the determinant of the leftover, second determinant of the leftover, third. Remembering that you're keeping the sign of the first one, you're taking the opposite sign of the second one, keeping the same third sign of the third one. So I want you to do the same thing here on this second example. You should come up, I want you to try it on your own, should come up with the answer -35. So remember, you're keeping the sign, you're opposite, so this is -5, and then you're going to keep it for -1 times the determinant. Work that out and come tomorrow and see if you can prove that you got the -35. When it comes to triangular matrices, it's very straightforward. You either have a lower matrix or an upper matrix. And in this case, the diagonal determines. If I have numbers below, that's a lower matrix. If I have numbers above, that's called an upper matrix. Okay? If I have zeros all over the place, it's called a diagonal matrix. And in order to find the determinant is to multiply all the options. So on the diagonal, multiply, that's the determinant. On the upper, multiply the diagonal, that's your determinant. On a straightforward diagonal, multiply it, that's your determinant. So with triangulars, it's very nice and easy, but you just need to recognize that they're triangulars, which means it has to have zeros all on one side and numbers on the other. Zeros on one side, numbers on the other. Zeros on both sides. And those are our triangulars. So that's going to be 8.4.